we can put our information into a table where we have clock time t in millennia, 0 through 20 by increment of 5. We have the rate in decays per second. Rounding off to consistent number significant figures, we have 5.0, 3.7, 2.7, 2.0, and 1.5. Now, what we're after is the total number of decays over each period of 5 millennia. How are we going to get from decays per second to the number of decays in 5 millennia? Well, the first thing we're going to do is we're going to take our rate and we're going to express that in terms of decays per millennium instead of decays per second. Now, how do we get from decays per second to decays per millennium? Well, there's 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 and a quarter roughly days in a year, and 1,000 years in a millennium. If we put all that information together, we see that we have 3.2 times 10 to the 10th seconds per millennium. That's about 32 billion seconds in a millennium. If we have 5 decays per second, then in a millennium we'll have 5 per second times 32 times 10 to the 10th, 3.2 times 10 to the 10th seconds in a millennium. And we're going to then end up with 1.6 times 10 to the 11th decays per millennium. Treating the other quantities similarly, 3.7 per second times number of seconds per millennium is going to give us a number of decays per millennium. And we're going to end up with these numbers of decays per millennium. Now we want to take this information and translate it into the total number of decays over a 5 millennium period. Well, the first 5 millennium period starts out at t equals 0 with 1.6 times 10 to the 11th decays per millennium. But at the end, it's down to 1.2 times 10 to the 11th decays per millennium. And over each 5 millennium period, we have a starting rate and an ending rate. In order to accommodate the fact that we have a starting rate and an ending rate over each period, we average the two rates. So we get an approximate average rate over that millennium. This is not necessarily an exact average rate. It's only an exact average if the number of decays goes down in a linear fashion, which this one obviously doesn't. In any case, averaging the decays at the beginning and end of the first 5 millennium period, we see that we have an average rate of 1.4 times 10 to the 11th decays per millennium. Over a 5 millennium period, the number of decays will be 5 times that. 5 millennia times 1.4 times 10 to the 11th per millennium gives us 7 times 10 to the 11th decays. We make similar calculations, taking the average approximate rate for each of the 5 millennium periods and multiply that average rate by the 5 millennia to get the total number of decays. We can then add these decays and get the total number over the entire 5 millennium period.